Oh, today we're going over section 5.1, which is angles in standard position in quadrant 1. So key parts of angles situated on a quadrant grid. We typically have a line that comes out from our origin. It is referred to as our terminal arm. The angle between that and our positive x-axis would be our actual angle. Our x-axis where we start is known as our initial arm and starting place of all angles. We often represent angles with the Greek letter theta. It represents an unknown angle. And just a review for our quadrants and angles. Our quadrants start as quadrant 1 here. Then as we go around, quadrant 2, quadrant 3, quadrant 4. And same with our angles. We start 0 here to here we're 90. Then 180, then 270, then 360. So our first example, draw angles of 65, 10 degrees, and 50. So for this, we're just going to estimate what our angles are based off the fact that we know that this is 0, this is 90. So therefore, for example, 65 is close to 60, and 60 out of 90 would be 2/3, so we would draw a line 2/3 of the way to 90, so probably something like this. And then label it 65 degrees. Just right. 10 next is 10 out of 90, so it reduces to 1/9, so we're about 1/9 of the way to 90, so I probably estimate 10 degrees to be something like this. Next one is -50. So that's an angle in a negative direction. So we won't be up here. We will be down here. And then 50 is roughly half of 90. So therefore we should be just over the halfway mark. So this would be our angle of -50. Also a reminder of our basic trig ratios that you would have learned about in previous grades. We had SOHCAHTOA to remember them. So with all of these, the first layer is our trig ratio. Second layer is what's in our numerator. Third is what's in our denominator. So this first one, SOH would be sine theta is equal to our opposite over our hypotenuse. CA is cos theta is equal to our adjacent side divided by our hypotenuse. And TOA is tan is equal to our opposite side over our adjacent side. So these are our basic trig ratios. Now we'll do an example that utilizes those. So for example, point 3, 4 lies on the terminal arm. We're going to find A, the distance from the origin, B, the 3 primary trig ratios, and C, our angle to the nearest degree. So the very first thing is I would draw out a coordinate grid. We'd then figure out where roughly 3, 4 would be. We'll draw our terminal arm to that, and then we'll draw a vertical line to help us form a triangle. This right here would be our actual angle, and we can label 2 of these sides. 3 is our x value, so that's our horizontal side. 4 is our y value, so our vertical side. Now to get our hypotenuse, we can use something you learned in the past, which is Pythagoras. So that's c squared equals a squared plus b squared. So we have c squared is equal to 3 squared plus 4 squared. So c squared is equal to 9 plus 16. So c squared is equal to 25. And then we'll take the square root of both sides so we can get c on its own. So c is equal to 5. Part B is writing out our primary trig ratios. So we know sine is our opposite side over our hypotenuse. Now our is opposite our angle. So our angle is here, so our vertical will always be our opposite when we're dealing with trig. And then our hypotenuse, we know is our longest side. So we have our opposite of 4 over our hypotenuse of 5. Cos of our angle, we know is equal to our adjacent side divided by our hypotenuse. Our adjacent side would be this side here, so that's 3 over 5. Next, we have tan of our angle, which is our opposite over our adjacent. Our opposite is 4, and our adjacent is 3. Now, part C, we can use any one of these trig functions to get our actual angle. So for example, I can take sine of my angle is equal to 4 over 5. And rearrange that to get my angle. So my angle is equal to sine -1 of 4 over 5. And that gives me an angle of 53 degrees. Okay, next example. Point x comma y is on the terminal arm in standard position such that it makes an angle of 50 degrees and has a radius of 6 centimeters. We want to find the coordinates of P to nearest hundredth. So for this, we will once again draw out the situation. We have an angle of roughly 50 degrees. And our radius is 6, which means our hypotenuse is 6. We know if this coordinate is given by x comma y. We don't know what x and y are though. We do know that this is 50 degrees, so we can use basic trig to get these two sides. So for example, if I want to solve for this side, which would be my y, this is my x, then I can use basic trig. So my y is my opposite, this is my hypotenuse. So the trig ratio that has opposite and hypotenuse is sine. So we have sine of our angle is equal to opposite over hypotenuse. We want to get our opposite on its own, so we would multiply both sides by the hypotenuse. That gives us hypotenuse times sine of our angle is equal to our opposite. So we have 6 sine of 50 is equal to our opposite. Now 6 sine of 50 is 4.60. We're going to nearest hundredth, so that's 2 decimal places. So we know that this is 4.60. Next, we'll find our x value. It's our adjacent side. We start with our hypotenuse, so I'll use cos. So we have cos of our angle is equal to adjacent divided by hypotenuse. Do the same thing as we did last time, multiply both sides by the hypotenuse. So we have hypotenuse times cos of our angle gives us our adjacent side. So we have 6 cos of 50 is equal to our adjacent, which is 3.86. Writing this as a coordinate would be 4.60, comma 3.86. Next thing is special triangles. You need to know these for this course, so you need to memorize them for this course, but you also need to know them for Precalculus 12. They're used for when we have angles of 30, 45 degrees, and 60, and they give exact values for ratios. So whenever you see a question asking for an exact value, there's a good chance you're going to be using your special triangles. Now, I'll go over how to get the side lengths for these triangles in case you forget how to get them. So, first one, we have sine of 30. That gives us 0.5 if we put that in our calculator. Now 0.5 is 1 over 2. And we know sine is our opposite over our hypotenuse. So opposite 30 would be 1, our hypotenuse is 2. We would then use Pythagoras to get this side, because essentially we'd have 2 squared plus 1 squared, 2 squared equals 1 squared plus b squared. So 4 minus 1 is equal to b squared. 3 is equal to b squared. So square root of 3 is this missing side. So our sides for our 30, 60, 90 triangle are 1, square root of 3, and 2. For tan, if you forget what the side lengths are, calculate what tan of 45 is. That's going to give you 1. 1 is the same as 1 over 1, and we know tan is opposite over adjacent. So that means these two sides are each 1. We had then used Pythagoras to get this side. So we have c squared equals a squared plus b squared. So we have c squared equals 1 squared plus 1 squared. So c squared is equal to 2. So c is equal to square root of 2. So in our 45-degree triangle, both sides are 1, and our hypotenuse is the square root of 2. Now, practice for this section starts on page 409.